We are going to, sorry, it's not recording quite as fast as I thought it was. So let's start this again. We are going to talk about the different trends in the periodic table. So the things that we're going to be looking at are, we're going to look at, my pointer doesn't seem to want to work here. Hold on. We're going to look at atomic number and mass. That's going to be our starting point. It's actually a good reference because that one we can see clearly on the periodic table. We are going to talk about the atomic size or radius of the periodic table, as well as the ions on how their patterns or trends work. And there is a nice graphic in your textbook on that one. And I don't have orange, so let's pick green here. Again, we will have electronegativity or ionization energy here, telling us about how they bond or form atoms. So let's look at the first trend here. Atomic number and mass. So what I want you to look at is what we're saying is this guy right here is representing a periodic table. So in your notes there is actually a periodic table being drawn for you. And what we want to look at is the trend. So I'm kind of use colors a lot to help us so we can get these pictured in our heads and maybe remember the colors too. So we're saying as we go from left to right, so we're going in this direction, the atomic number and the mass get bigger, which makes sense because hydrogen's mass is only 1, and we end up getting to 10 over here with neon, so we have 2 and 10. And then we're going down the periodic table, we also get bigger. So we have mass of 1, and then we go to 2, or element number 2. So as we go down, we're also getting bigger. So that one we can see very clearly on the periodic table. So I like to use the ramps to help us better understand what's going on. And I do like to have this represented on my periodic table or on my handouts a special way, so I'll help you with the note cards when I return. So our next one, sorry, let me erase this. Our next one is atomic radius. So I usually draw him in the box to the right if you're trying to make a note card. And this guy, we're still saying this box right here is our periodic table. So we're using the word radius for size. As we go from left to right, we're actually getting smaller. So from left to right, we're getting smaller this time. And this is due to shielding. So I'm writing that out there. It is here in your notes here eventually, but at least that way you can see it. It's due to shielding. And that looks really ugly, sorry, but at least we have something. Okay? And then as we go down the periodic table, we do get bigger, and that's due to energy levels. Okay, so left to right, we get smaller, and then as we go down, we get larger due to energy levels. Keep in mind, trying to measure that radius is pretty hard because we don't really know where the edges are on an atom. So we're actually looking at the center between two nuclei there. So we have the shielding and left and right getting smaller, and as you go down we're getting bigger. So here we have a picture in a nutshell showing you that. So once again we can see on this side we're starting off kind of big, and then on this side we're getting a little small, and then as we go down we're getting super big. So we can see that those are our atoms, and we have just that little dots over there. So we're medium, and we go to the right side, we get teeny tiny, and as we go down, we get super big. And it does say about the attractions in there. So there's a fancy word in there called shielding, or it should be in there. Whoops, erase that. All right, we're not erasing here. Okay, so looking at it now, same image, we're talking about going down and we're talking about energy levels. So the left to right is because of attractions or shielding. And then as we go down the periodic table, we're looking at the energy levels getting bigger. So you can focus on those. So to wrap that up, why are they larger going down? Higher energy levels have larger orbitals, and the shielding is not quite as important. So we want to focus on the keyword here, energy levels, for this guy. And then why do we get smaller to the right? We're looking at shielding there as being the most important. So atomic radius, we're looking at those features. Here's another picture to help you see that. And from another textbook, I thought that was helpful. A lot of books show arrows, and I don't think of arrows as indicating size. I just think of them indicating direction. So that's why I like to use the triangles instead. Now, ionic radius is a little different. It's kind of like radius, except we are dealing with this idea. So here's our periodic table again, our little fake periodic table. We start off big and we get smaller, and then we have a spike, and then we get smaller again. And this is because on this side we have cations, and then on this side we have anions. So we have different things there. So there is a figure in your textbook that I'll have you look at some things to evaluate that and ionic radii versus regular radii. But as we go down, it's still the same trend where we're getting bigger because we're still dealing with energy levels. Our last trend, so this one's pretty short, this is our last slide for today, or for this portion. Our last trend is looking at electronegativity or ionization energy. Oops, and I lost my writer there. So as you can see, the first ionization energy is how to remove an electron from a neutral atom. Electronegativity is saying how strong that atom attracts electrons when it is in a compound. And reactivity, that trend is the opposite of electronegativity or of ionization energy. So the less energy needed, the more reactive it is. So as we go from left to right, the electronegativity gets bigger or ionization energy gets bigger. But as we go from top to bottom, the energies get smaller. And that helps us understand that the guys down at the bottom are the least or the most reactive, the least amount of energy. And there is a value on your periodic table, so you don't have as hard of a time memorizing this. But you will have numbers on there, and it's not an exact trend, but it is a general trend. So we will look at that in the lab when we return from break. And if it's not break, sorry, but when I made this video, it's going into Thanksgiving break. So we will look at that trend in the lab. And doing some demos with some metals, and I will try to also have a video for you to watch to see some of those. It's kind of a silly video from some British group, so we will look at that too. So there you go. That's it for understanding the periodic table. We'll look at electron configurations. Possibly when we return, or depending on time, you may get a chance to look at those in class. But I think I'd rather you work on your bonus work before break, and we'll do electron configurations when we return. So have a great break, guys. I will see you when I return.